Welcome. In another video, we learned about the impact of multiple compounding of interest on the way we analyze cash flows. And here we will learn about the impact of inflation on also the way we analyze cash flows. So what is inflation? It's like we covered before. We compared actually inflation to time value of money, but inflation is the decrease in the purchasing power of money due to the increase in material prices without really adding value. So it's the same egg that we had 50 years ago. It costs less than the egg we have now. Maybe even the eggs now we have a little bigger in size a little, but the increase in prices is tremendous. So the impact of inflation can be significant. It depends on what type of investment you're working on. So in the US, inflation is significant, but not that much compared to other countries where they have inflation significant, great changes in prices from a year to a year. So the opposite of inflation is deflation. So in the cases when prices actually decrease. So generally prices increase. It's kind of a given rule in life that always prices will keep increasing. So the inflation is represented by inflation rate, which inflation rate is calculated based on an economic metric called Consumer Price Index. And in the US, Consumer Price Index is published and tracked by the Bureau of Labor Statistics. And what they do is they go to the market, the economic market, and they collect the prices of around 80,000 commodities in 87 urban areas. So they do that massive kind of data collection, and they track what's the change in prices, and represent that as a index called Consumer Price Index. And Consumer Price Index is based on year 1982 to 1984. They fix this year as kind of the datum or the base, which CPI value is there 100. It's unitless, so CPI is just 100. And you see, like I can see here, in 1980, 1984, that's around 100 CPI. So before that, the prices were cheaper, so CPI is less than 100. And after that, the CPI is increasing to reflect higher prices. So this is the blue curve. The red curve is the change in the CPI, which is a reflection of the inflation rate. So you see here recently, since 2000s, inflation is ranging from 4% and 1%. In some cases, like you see in the economic meltdown 2009, it went almost to zero. I'm recording now, this is during the COVID-19, and inflation is really close now to zero also. So usually inflation goes down when something is going wrong with the market. And it goes down also it's related in some way with the interest rate, the federal interest rate. So this is not a macroeconomic class, so it's only project engineering economics. But we need to acknowledge that inflation affects prices of things, and prices are reflected in our cash flows. So the same equipment we buy now, we'll have to buy it in years much more expensive than now. So how to account for inflation? We have first to learn about some terminologies here. Constant dollars cash flow. So that represents a cash flow that's represented into the dollars of now. Like if the equipment is bought by $10,000 now, then I represent its cash flow. What that happens, let's say I will buy it again after 5 years, I will put the cash flow for it as also $10,000. So I don't change, it's the same equipment, same everything, so I don't account for inflation in the numbers that I represent this cash flow with. The then current dollars cash flow is now different. It includes the inflated prices of things. So the equipment that's 10,000 now, I'll put it now as a 10,000, But if I represented the cash flow considering the then current dollar cash flow, in 5 years it might not 10,000, it will be probably 12, 13,000. So that's the difference between two types of cash flow: constant dollars cash flow and then current dollars cash flow. So let's see the difference between both in this example here. So the family here anticipates spending $5,000 every year in groceries and accounting for 3% inflation rate. What will be the then current dollar cash flow for the groceries over 4 years? So if I'm dealing with constant dollars, if I'm drawing a cash flow here, it will be very uniform cash flow, right? It will be the same value. I'm not inflating the numbers. But the then current dollar, current value of the groceries is $5,000. So if I'm already going through the first year, so remember we put the arrows at the end of the year. So during that year, inflation already kind of happened. So this 5,000 becomes 5,000 times 1 plus 3% inflation. So the first year kind of I accounted for inflation. Second year I accounted for more inflation above the inflation that happened before. So we end up with the fourth year. I expect the groceries here to cost the family around $5,627. So you see the inflation compounds similar to the interest. So the formula to relate then current dollar to the constant dollars is kind of similar formula to the time value of money. So the then current dollar is equal to this dollar T variable is equal to the dollar C variable, constant dollars, times 1 plus F, the inflation rate to the power K, which is the time periods, which is equivalent to N when we dealt with F given P factor. And you can look at it the other way, so the inverse of the formula. And I can actually also use the interest tables and formulas to calculate inflated prices. So because it's the same mechanism, it's the same compounding of a value over time with a rate. In our case here, the rate is inflation rate, not interest rate. So next terminologies to cover are related to the interest rate. So there is a real interest rate, which doesn't account for inflation, and there is the combined interest rate, which assumes that whatever rate you get reflects the return on investment or earnings, and plus money that you will use to cope with inflation. So when you go to the bank and open an investment account, they give you like 1%. Think about it, is it a real interest or combined interest? So a real interest would say, all right, I will give you 1%, and then I will give you 2% more extra accounting for inflation. So together will be combined 3%. But typically it's just saying, I will give you 1%, 1.5% return. So they expect you to use that return to adjust for inflation. So it will be kind of a combined interest. So here the formula for relating combined interest to real interest is shown like this. So I can calculate I combined if I know I real and the inflation, or I can use calculate the real interest if I know the combined interest and the inflation rate. So IC combined and IR real, I real interest. So in this case here, if we are given inflation of 3% per year and we have 8% real interest rate, kind of someone say, I will give you 8%, and on top of that I will also account for 3%. So together, kind of, instead of just dealing with two rates, what would be the combined rate of both? So it's not a simple addition, it's something else, that IR plus times F, this third term. So if you want to have a combined interest, then it will be 11.24%. So now we learned about the different terminologies. We have two types of cash flows and we have two types of interest rates. So the question is which one to match to solve a problem or analyze a cash flow. And whatever approach you have with these matching of interest rate and cash flow, you should end up with the same worth of cash flow you are actually calculating. So the two approaches we have are like, let's name them by the type of cash flows we are dealing with here: then current dollar analysis and constant dollar analysis. So in this one, cash flows are represented by as shown in the names. So every approach will use that corresponding cash flow representation of this engineering alternative or project. But the interest rate that you will use is for the then current dollar, which includes inflation. You will counter that with the interest rate that includes inflation, which is the combined interest. For the constant dollar analysis, you have a constant dollar cash flow, doesn't have the inflation into it. So you don't use the interest rate that has inflation, use the interest rate that's real interest rate, that's free of inflation. So that's the way of you matching interest rate to the different cash flows you have. So let's explain or show the use of both approaches in this example. So kind of revisiting example one of the grocery example, but now the family wants to figure out how much do they need to invest now. Like, let's say I don't want to worry about groceries, kind of thinking about, it's funny, having an investment account just for grocery, not like for college. But let's say this is the case. So we have here, this investment is giving us 6% compounded annually at its combined interest. And the inflation is 3%. So how much they should invest? So we're basically asking for P, the present worth here. So remember, we did this exercise before, but showing here this table of how a cash flow would look like if we're using constant dollars or we're using then current dollars. So if I'm going to solve that, I will say which approach I will use, and we'll actually use both to compare. So the first approach we'll use is the then current dollar cash flow. And it starts with 5,150, if you remember from the previous screen. And I don't have to draw the value of each one of the other arrows that are increasing with a 3% inflation, because I kind of recognize that it's a geometric series. So geometric series, I care only about the first cash flow in that series, which is A1. I need to know what geometric rate that this A1 is increasing in the next years, so 3% inflation. And I, in this case, if I look at it's a then current dollar cash flow, so it has inflation, so I need to use the rate that has inflation. So this is the setup of the problem. It ended up to be a geometric series of cash flows, and I need to calculate the present worth of that. So we're going to use the P given A kind of factor. The P here is negative, so an A here is positive, so they invest now, so they're kind of getting out of their pocket money, put it in the bank. It's in the bank, not in their pocket. It's an out cash flow. And then they get from the bank this cash and they spend it on groceries. So here we have I, we have J, we have A1. We just need to plug in the values, and we'll find that P here would equal to 18,624 and change. So they need to invest that money to be able to get cover the groceries expenses in the next years. So if we decide to ignore that this is a geometric series, then every arrow of these in this cash flow, I need to get the value from the table from the previous screen, and then I will deal with it as, multiply by P given F value. So the first one, I discount a 6% rate, so I divide by 1.06 and keep going like that with the other type of cash flows, or the other cash flows in the years 2 to 4, and you will end up with very close value to what you get. So it's the same answer. Like with rounding error, it is really the same answer, just different approach within that approach of the then current dollar cash flow. I can lump these payments as a series, geometric series, or deal with it as a single sum, every one of them. The second approach is constant dollars cash flow. So For constant dollar cash flow, I need to calculate now the real interest rate, which will turn out to be, using the formula here, will be 2.913%, less than the real interest, the combined interest, which was 6%. So drawing the cash flow, I will have to figure out P, but now my cash flow is a uniform series cash flow, because now I'm dealing with constant dollar 5,000 grocery expenses over the years. So I'm using here the P given A factor. So I'm given A and I'm trying to calculate P. Let's say I will use just the formula here. So plugging in the values, and I will end up with a factor of 3.724 as a P given A. And I will end up with the same answer. Again, ignoring the rounding error, but it is really the same answer. So either approach will give you the answer as long as you match correctly the interest rate with the corresponding cash flow for it. So that's it. We've seen now the impact of inflation on cash flow. You have to be careful when you draw the cash flow and matching it with the interest rate, either the combined or the real. And generally that will be something to pay attention to in such specific problems. But if nothing mentioned about inflation and nothing mentioned about what type of interest rate is that, you will just proceed as if it is a constant dollar interest rate, and the interest rate constant dollar cash flow, and the interest that's given to you is a real interest. All right, that's it for this video. Take care.